If you're just joining, here's where we left off. In the last video, we walked through how an ECS actually stores its data. Components packed together, grouped by archetype. This time, I want to zoom in on the smallest and most deceptively simple piece of that whole system, the entity itself. Here's the problem that makes it interesting. Say you spawn an entity, hand its reference off to something, a targeting system, a projectile, whatever, and then that entity gets destroyed. Later, you spawn a new entity, and it happens to reuse the exact same slot the old one lived in. Now your projectile is still holding what looks like a perfectly valid reference, except it's pointing at a completely different object. Nothing crashes. Nothing warns you. Your homing missile just quietly locks onto the wrong target. That's the failure I want to design against. So what actually is an entity? In an ECS, the entity isn't the object. It doesn't hold your position, your health, your mesh, none of that. The entity is just a key. It's the thing you hand back to the storage to ask questions. Which archetype does this belong to? Which components does it have? Is it even still alive? All the real data lives elsewhere. The entity is the handle you look it up with. And because it's a key, it has two jobs to do, and they pull in slightly different directions. First, it has to be tiny. Minimal, cheap to copy, stack-friendly, and easy to hash, because we're going to use it as a lookup key constantly, in maps, in queries, everywhere. Second, it has to encode presence. It can't just say which object. It has to carry enough to answer, is this reference still the one I think it is, or has this thing been deleted out from under me? The way I solve both at once is almost embarrassingly compact. The entire entity is one unsigned integer. No struct, no pointer, no allocation, just a number. You'll see this done as a U32 or a U64. I size it to a CPU word so it moves around for free, and since basically every CPU today is 64-bit, I'm using a U64. But I don't treat those 64 bits as one number. I split them in half. The low 32 bits are the ID. That's the actual identity, the slot this entity lives in. The high 32 bits are the version, a counter that tells me which generation of that slot I'm looking at. Here's how the version earns its place. Every time I destroy an entity, I bump the version of that slot. So when a new entity moves into the old slot, it has the same ID, but a higher version. Now go back to our missile. It's holding a copy of the old entity, old version and all. When it asks the world, is this still valid? The world compares the version baked into the reference against the current version of that slot, and they don't match. Stale reference caught, cleanly, with a single integer compare. The full lifecycle logic is its own topic for another video, but that mismatch check is the whole reason the split exists. So how do you actually pack two numbers into one? This is just bit manipulation, and it's worth doing slowly. To build an entity, I take the version, shift it left by 32 bits so it sits in the top half, and bitwise OR it with the ID sitting in the bottom half. One integer, both fields, no overlap. To read the ID back out, I mask and the value with a constant that's 32 1 bits in the low half. Everything above that vanishes, and I'm left with just the ID. To read the version, I shift right by 32, dropping the ID off the bottom and leaving the version behind. Shift to write, mask, and shift to read. That's the entire trick. And that's the entity. One 64-bit integer, split into an ID that says which slot, and a version that says which generation of that slot, light enough to pass around and hash freely, but just clever enough to catch a reference to something that no longer exists.